Good morning, everyone, and welcome. I'm very delighted to host you today for the fifth and final episode of the React Cluster webinar series. For those new to us, React stands for Resource Efficiency and Automation for Circular Transformation. This cluster is a collaboration action among several projects, all working together towards enhancing the European industry and infrastructure through cutting-edge technologies. Today's webinar is organized by the Tubers project, focused on the crucial role of AI, data, and robotics in improving the efficiency of critical European infrastructure and the industry. So we are going to explore all together how these technologies are shaping these vital sectors like sector of energy, water, transportation, manufacturing, from intelligent data-driven decision-making to autonomous robotic inspection and maintenance solutions. So before we begin, a quick note on the format. So each speaker will present by themselves from approximately 10 minutes. So please stick to the timeline so we can all have the time to have questions and discuss. Following its presentation, we will have 5 minutes for questions. So let's dive into our agenda for today. So first we have Tubers project. So we have Joël van den Bos from ALCHIMIA presenting the Tubers project solution on the flow of innovation, AI, data, and robotics in water infrastructure. So the floor is yours.
Good morning. So let me share my screen so you can have an idea of the presentation. Okay. The PowerPoint presentation. And yes, I'm Joël van den Bos from ALCHIMIA, and we have prepared for you a presentation regarding the use of AI, data, robotics in critical water infrastructure. So we've put that together with colleagues from THL. So what are we talking about? Why AI, data, and robotics are linked to critical infrastructure, and why is it important? In our vision, we think that AI, data, robotics can be critical for the efficiency of the critical infrastructure over time. And this topics has been explored in many instances. You're going to find a lot of publication on the website. Here I took 3 examples. But basically, if you want to enhance the productivity and the competitiveness of your critical infrastructure, like drinking water pipe networks, you have to improve the efficiency. And in the planet Earth, because of this specific characteristic, we believe at least that let's say the vision of the Tuber project is that if you want to increase the productivity and competitiveness of your infrastructure, you have to improve the energy efficiency, how you convert the energy you need to do the job. And the job could be limiting the water loss due to leakage, for example, because the more leakages you have, the more energy you need to produce water that can be delivered to you end user, and the less losses you have, the less energy you need to improve, for example. Same things if you want to do repair on your networks. The more you want to do repair, the more people, the more resources, the more toolings you need. It translates into more energy. So if you are able to convert this energy with efficiency, you increase the productivity and the competitiveness of your infrastructure. Now, in the case of this project Tubers, what are we talking about? Basically, we're talking about the drinking water pipe distribution networks. And the ambitious goal to help to eliminate non-revenue water and leaks in those pipe networks. So on the left of the slide, there you can visualize what type of pipe network we are talking about. We're not talking about the pipe network within the boundaries of your residence or the building, but the pipe networks connecting the drinking water production plants and these boundaries of residents, for example. So we're talking about very complex pipe networks from internal diameters ranging from less than 100 millimeters to about 400 millimeters. There are about over 4 million kilometers of these networks over Europe. And due to the age and the degradation, end of the day, you suffer from light leakages, micro leakages. In some cases, some water companies, utilities, and municipalities are very efficient in driving the flow and the pressure that goes inside those pipes and reduce the water losses to a couple of percent, less than 4%, 7%. And in other cases, unfortunately, it can amount to more than 20%. So on average in Europe, it's still a large number, in spite of all the efforts that has been done in order to manage these pipes, manage the water running, and also manage the replacement of these pipes. Some of these leaks, as you see in the middle of the slide, are visible because a small portion of these pipe networks are in air, but most of the networks is installed underground. So whenever you use sensors, you feel like that you're losing pressure, you have mass balance problem, you suspect that one section has a problem, okay, you have to dig in, you have to do all the work and make the replacement. So it's a very heavy type of situation, and you interrupt the service to your customers. So that's the situation and why we're so interested in solving this problem. And what we are experimenting with is obviously AI data robotic solution for the inspection, the monitoring, and the repair, so the leakage repair inside the pipe network in service while the water is running, so you don't have to interrupt the service to the end user. So we are currently building and finishing the integration of the prototype that will test in a test installation that you see on the right side of the slide, which is above ground because it's easier. And okay, we can't show you the whole solution that we're building for EPR situation, but basically you have to figure out that we will introduce in the pipe networks what we call robotic carriers, let's say robots, so device that can travel inside the pipes and navigate the geometries of the pipe networks. And these robotic carriers will carry the tooling and the instruments for the inspection. Typically, to keep it simple, it carries a vision system. So instead of looking at the pressure and the flow of the water, we can directly look at the integrity of the pipe walls of the networks, and the other carriers will carry the tooling in order to repair the repairable leakages by spraying resin at the location of the leaks. So just in short, and just under on the right side, you have the participant of this great project. Now, in terms of impact, so what we envision if we are successful end of the day with this project, this is a bit the business case and how sustainable we can contribute to the whole situation. If we're able to repair one leak out of two, for example, it will correspond to, in Europe, to the elimination of over 150 gigawatt hour of energy, whether it's low carbon or carbon-based energy that you use to produce water, because there will be less leakages, so less energy needed to produce the needed energy for the end user, which correspond to close to 80,000 ton of CO2 emission. That's over a 5-year period. And also in terms of preserving scarce resources or very vital resources for human activities, it's over 10 million cubic water a year, which is about in non-revenue water. You pick whether 1 cubic meter of water is a value of €1 as in your invoice, or less than that or more than that, and it gives you the idea. To give you a reference point, a large city like Paris, it could be Amsterdam, it could be another city, it's the energy requirement to live in these cities for the population is around 15 gigawatt hour of a power of 150, more than 150 gigawatt hour if you take into account the infrastructure like the subway, the public transportation, and these kind of things. So that gives you an idea about why is it so important and why we want to use technology to address that. Now, in using technology, what we are looking at in terms of the use of AI, data, robotics, here are 3 examples, let's say 3 level of examples. So in the entry level value, as we have seen, it's about inspecting, repairing leakages, and monitoring the integrity of the pipe networks, where we use robotics, data, AI solutions, so the vision systems and different instruments for the localization, positioning, and mapping of the defect, for example, and those kind of things. And as a result, we envision an impact that would eliminate up to a certain level the non-revenue water, generate energy saving and CO2 emission being saved. And then obviously for the municipality, the water companies, it can translate in better performance in terms of avoiding leaks and avoid a number of unplanned intervention because there is a burst somewhere, and that requires immediate intervention with a lot of resources. Now, in the second level, conceptually, it's going to be 10 times more valuable because we can use the data and the AI in terms of better decision on allocating the efforts and the resources from the maintenance crew or the intervention crew. So you can imagine that if you have inspected enough section of your pipe networks for a water company, so a large water company can operate pipe networks under 2,000 kilometers or up to over 20,000 kilometers, but already having a better knowledge what's the integrity or non-integrity inside the pipe network for 100 kilometers, 1,000 kilometers will help to better plan the maintenance and intervention according to the level of degradation. So you need less effort, less energy in order to keep or to improve your performance in terms of non-revenue water and leakages, for example. And also it means supplying water to you user thanks to the use of this AI and data. Now, if you go another level, which could be conceptually 10 to 100 times more valuable, is then the use of AI and data to drive or to assist the operation of these water companies, utilities, and municipalities. How is that possible? So if you have an extended view on your pipe networks, you can start to look at the lifetime management of these pipe networks, because you're talking about pipes that will be installed for decades, hundreds of years, and basically you have to replace them. So with better knowledge, you can plan where to invest. For example, you 1% a year replacement or 0.5% pipe replacement a year, whether it's better in this section because of the knowledge and the inferred degradation for the future years, instead of doing that a little bit intuitively or based on tacit knowledge from human. Also, you will accumulate it through times a lot of data which are not available today. Today, you don't have visual data or non-destructive test data from installed pipe with running water. You have to wait till the pipe is getting replaced to study that after 10, hundreds of years of use. Now, having this data can help, at least that's the hope and the ambitions, can help you to understand better the degradation mechanism. And if you understand the degradation mechanism on a more practical way, you can probably also at least attempting to develop not the repair mechanism, but the preventive repair mechanism. Because the question is why waiting for a leak to do the intervention. Can you imagine develop like a tape type of preventive repair that can be applied robotically? So you do the intervention before the leak happens to keep a perfect integrity of your pipe networks. And if you have data about how many repair you have done and whether the label and the characterization of the leaks you have repair is about 5 liter a minute to 10 liter a minute. So you have an idea of about how much water you have saved from leakages, which corresponds in a certain way to how much water you have preserved from where you extract the fresh water you need to produce drinking water. And then inevitably, you can also better manage this reserve since you have saved, for example, for the past year, so many cubic meter of water. What can you do with this and be clever about this water you have saved? Whether you can redirect it for agriculture or save it for the future generation. So that's the topic we wanted to present to you in a very quick overview and simplified view for you to give an idea of the vision about the use of AI, data, and robotics for hopefully better management in critical infrastructure like drinking water pipe networks.
So thank you, Joel, for that insightful presentation. We now have 2 minutes, sorry, for questions. Feel free to type your questions in the chat or raise your hand. If not, we can continue with the CLARUS project. Joining us from Ikerland, representing the CLARUS project, we have Aitor Aguirre. So Aitor will be discussing CLARUS MLOps, automating data and AI model sharing in the European food industry. Aitor, please take it away for your 10-minute presentation. Thank you.
Okay, thank you. Let me share my screen. So can you see it?
Yes.
Okay. Good morning. I am Aitor Aguirre from the Data Ops team at Ikerland. We are the leaders of PP4 related to the AI toolkit in the CLARUS project, and more specifically, we support the MLOps framework in this project. So I will dive a little bit into it. I will briefly introduce the CLARUS use cases and the AI toolkit, the MLOps needs we need in the context of the project, and the solution we have developed and provided to the other partners to cover these needs. Okay. So just to briefly introduce the project, I would summarize it saying that CLARUS tries to improve the sustainability of the food industry in Europe by using AI technologies. We have two use cases. One is focusing the production of frozen food in Valencia, and the other one in the production of meat byproducts in Tampere, in Finland. In the first use case, AI models are used to reduce the energy and water consumption of the plant. Whilst in the second, AI-driven logistics are developed to reduce energy consumption, fuel consumption in this case, and at the same time, maintaining or guaranteeing the best possible product quality. So in this context is where the CLARUS MLOps platform comes into play, as we try to support the whole life cycle of the AI models. Moreover, it leverages the idea space, CLARUS data space, which is part of PP3, to share data and models between the different stakeholders. On the one hand, the pilots, on the other hand, the AI providers. And the platform also integrates the calculation of the green deal index, which is one of the other technical expected outcomes of the project. Okay. So in CLARUS, we follow a data ops approach, trying to automate the full life cycle of the AI models, starting from the data acquisition and processing, through the model training, the validation of the models, the deployment into production, and finally the monitoring of these models in productions, looking for eventual concept or data drift and so on. And in this sense, we have closed the loop, also allowing the automatic triggering of our retraining in case of data drift detection is detected in operation. Okay. And here we can see the open source toolset that we have integrated to cover different functionalities that I mentioned before. We are using Airflow for pipeline orchestration, MLflow for experiment tracking and model versioning. We Dockerize the models with FastAP for inferencing on the edge, and a library called Evidently for data drift detection also on the edge. Probably here the most interesting point is that we provide an integration with of the MLOps platform with the CLARUS data space over IDS, and more specifically through the True Connector provided by ENG, who is another partner in the project. Just an additional comment, the TouchSuite installation also includes Jupyter for experimentation and mining for model backend, and its integration with the IDS connector. Okay. Here we can see the overall architecture of the MLOps platform. We support an edge to cloud solution that allows, on the one hand, the data sets can be shared by the pilots on the edge. And on the other hand, the AI model providers can access these data sets through IDS, can train their models in the cloud, for instance. And the other way back, they can expose these models in the cloud to be further downloaded to the edge, the other way back, to the pilot's edge. This data and model sharing is performed through IDS, as I commented before. And this way, a trusted channel, we achieve a trusted, we provide a trusted channel that guarantees data security and data sovereignty. So, as an additional utility, the platform provides a graphical tool that assists the MLOps engineers in developing the Underflow, the DAGs, the direct acyclic DAGs, allowing a connection to the user's repos, in this case, the universities that develop the models. They can be, these repos can be hosted either in GitHub or GitLab. And the platform automatically scans these repos for functions and allows a graphical generation of the DAG through drag and drop functionality of the functions that are scanned in the repos. And finally, the platform is installed over a Kubernetes cluster. So in this sense, the graphical tool that has been developed also allows an MLOps engineer to define where the different tasks of the DAG are executed. And this way, we provide a better way to optimize the hardware resources that you could have on premise. This is the case of Hackerland, which also provides the platform for model training. Or even you could have a hybrid public or private Kubernetes clusters. This is also supported. And this is a brief summary of the supported features. We are currently working in the role-based access control, just to provide a way to establish priorities depending on the project, depending on the users, and so on. But the other functionalities are already supported. The platform is easily installed on premise, and it supports parallel training as it is installed over Kubernetes. So this is maybe the most important features. And this is all by my side. If you have any question.
Thank you very much for your presentation. Don't hesitate to ask any question. If there's anything, next we'll hear from Maria Pellegrino and Javier Grau-Frommer from IRIS, who is here on behalf of the Reclaim project. Marina will be talking about hyperspectral imaging for waste and material classification, reclaims portable material recovery facility application. So, Marina, over to you.
Well, I'm going to start first.
Okay, sorry.
Don't worry. Let me first of all introduce Reclaim, the AI-powered portable robotic material robotic in a box. The consortium is formed by 10 different organizations, four from Greece and the other ones from Netherlands, Spain, Germany, Belgium, and Malta. And let's say what is the problem why this project was born is to give some solutions about the urban central material recovery facilities. As you know, these kind of facilities usually are located in the areas with big populations because it's not profitable to be located in isolated areas. But for the waste management of these isolated areas like islands, rural areas, is sometimes complicated to have high efficiency in these material recoveries because to avoid transport costs, you need to compress all the materials, making more difficult all the sorting steps, making this so inefficient. And the same applies for the cases of big productions of waste in a located area like sport events or music festivals, let's say. With this kind of solutions, the case of Reclaim with this PRMRF, we are able to sort to sort all the waste in the just close to the source for the case of the islands, and to send this material sorted one after the process. But not only for these cases or these scenarios. This can work also for let's say new scenarios in the waste management. As you know, for example, the case of bioplastics with the new legislations, we need to recover this kind of new materials. So this can be also a solution for these new scenarios, putting this equipment next to the actual facilities to recover these new materials without changing the actual infrastructure or doing, let's say, big modifications in the actual facilities, maintaining the industrial efficiency and taking account that also the cost of this equipment, taking account all the materials that you can recover, has a good equilibrium, let's say, with this cost effective. When we talk about all the systems that are installed in the PRMRF, we have also is equipped with the perspective cameras that Marina are going to talk just after me. We have the part of artificial vision powered by artificial intelligence to not sort only by materials, to focus also in valuable items that that have some interest to be recovered apart, and also specific grippers adapted to specific scenarios that can be the films or some special items that we can find in the waste. And if all this system wasn't enough, also in the project we develop a recycling data game, let's say to improve the awareness of the citizens, because you know that is the first step, that is an important step. So we are trying to improve the knowledge of the citizens with a recycling data game that you can download in the Apple Store and Android Store. If you search reclaim recycling data game, you can find download it and play. And we are using, let's say, real data from the PRMRF to feed the games in the mini games inside this one to show, let's say, the citizens how all these systems improve that awareness, improving the knowledge. And if we say about the impact and the metrics, well, with the equipment is able to recover 6,500 items per hour and reduce 1.6 tons of CO2 emissions daily. And if we go a little bit further, if we talk about how AI and robots can help in the waste management, we have, let's say, like two separate areas that we can do, let's say, big improvements. On one side, we have all the part of the optimization of the waste collection with the garbage truck routes, not only for the urban waste, also for the industrial waste. This is so important because some of the companies that deal with this, they work with so many different types of waste, not only the most common. Also, they can work with, let's say, the dangerous waste. So this part of optimization with the sensorization of containers, the field level, weight, or some kind of automatizations in this system is so helpful to avoid a lot of costs of the transport. And also the other part that is sometimes complicated to manage is all the documentation associated to this type of waste, all the bureaucracy behind this waste management. And with this platform supported by AI and these optimizations in the routes are good solutions to all this waste management. And in the other hand, in the next step, in the part of the mechanical recycling and dismantling of the items, we have all these solutions of cobots that can help or make easier the works, or the people that are in these waste plants, helping them with all the heavy weights, the repetitive task, or the task that requires a lot of precision. Let's say making easier the life of the workers. For example, the case of the case scenarios of the electrical and electronic is a good example for this issue, or the automotive, helping them to recover, let's say, the most valuable parts. And related with that, we have, for example, also the virtual reality, where you can help the workers showing step by step how to dismantle and recover the most valuable parts to improve the recyclability of this complex waste, or make easier to avoid, let's say, some dangerous parts or dangerous waste. There are some examples. It's true that some of these solutions actually are not the cheapest one, but we are seeing a huge increase in the quality of the new hardware and new software. So this is going to be a good solution, I think, in a close future, I expect. And after that, Marina, the floor is yours. Just say me next when you want to change the slide.
Thank you. Yes. Then, good morning, everyone. As Javier already mentioned, I'm going to give you an outlook on our HSI-based system works. And first of all, it is important to address that each solution I believe for in particular for waste and material classification, needs to be adapted to the specific needs and to the requirements of the application itself. And that's what we did. At IRIS, it was developed an HSI system, both on the hardware and also on the software side, for waste and material classification. The goal is to provide a solution for real-time waste monitoring and classification for effective portable material recovery facility sorting operations. Why these type of spectroscopy device are chosen? Thanks to the ability of performing non-destructive analysis with a high spectral and spatial resolution, and as well the ability to capture spectra fingerprint from several objects simultaneously. So as you may see in the image above, we're able to analyze and to give material predictions on material chemical composition for several objects at the same time and provide several outputs at the same time. That, of course, it has to be integrated with the computer vision in the container. So this is just the I would say the spectroscopy side of it. In fact, next slide, please. Thank you. In fact, what have been our two main activity, our two main goals? We had a first part of data collection and analysis, and then the development of the geometric models. Related to the data collection analysis, the HSI technology captures detailed spectra for each pixel in an image. Since it's an imaging application, the unit is pixels, and for each image we produce a large quantity of data. The data needs to be interpreted and analyzed, and in this case geometrics came to help, because we are able through geometrics techniques to fulfill the needs of the material categorization. The models have been developed with both data collected at IRIS, at our facilities, and at the NPRF with real waste spectral data, and the database has been constantly updated. The reason for that is to access the most representative data and ensure that every characteristics of the environmental variabilities, of the chemical variabilities are taken into account. And so to have accurate and precise predictions. What are the classes that we are talking about, the type of materials? Metal-based objects, which are drinking cans, aluminum cans, ferrous cans, think about beans cans. Then paper-based objects, which could be Tetra Pak or paper bags or paper tissues. So then we have the polymer side. So we have PT, PE, PP, and PS materials. Next slide, please. Thank you. So where are now at the moment related to the HSI application development? We are at the validation stage, and we are happy to say that we achieved to capture most of the materials variability and to predict as well the materials variability, and to be able to correctly classify the composition, so the material type of the majority of objects that need to be sorted at the PMRF. For example, in the images, we can see that objects, in specifically domestic waste objects, are not composed of only one material, If you see, for example, in the PET bottle, we have caps, labels, as well as in PE bottles that are made of 2 different materials for caps, labels, and other components. But also, since it's waste, it could be accidental. For example, in the PP, objects, and we see the predictions at the right of the object picture. We see that is classified and identified a piece of paper inside the PP plastic packaging. That's normal, and so this is, I would say, also one of our main challenges that we came through. But since HSI is a powerful device, a powerful application, and also it has been integrated with other powerful vision and computer science application, we are happy to say that we achieved most of our goals in terms of material classification. And that will be all. Thank you.
Thank you very much, both Marina and Javier, for those exciting developments. We have now a couple of minutes for questions, and feel free to submit them in private message or raise your hand.
There is a question in the chat section, Irini.
Yes, I see it. If you want, I can answer it. It says, to train the models and continue training, do you store the full video of the perspective camera or just a subset? Thank you, Luis, for your answer. Unfortunately, since this is also a commercial application that we have, we are limited in the information that we can disclose on this site because it's our know-how. So I'm sorry, but that's a non-answerable question, but it's very interesting, and it's really smart because it makes a lot of sense. So yeah.
If nothing else, I would like to thank you both. And our next speaker is Dimitris Karamouslis from CERT, representing the Wood2Wood project. Dimitris will delve into how DPP improves the data management and interoperability concerning the wood materials. So, Dimitri, the screen is yours.
Yes, thank you. Just a second. Okay. Look, I hope you can see.
Yes.
So, okay. Good morning, everyone again. I'm Dimitris from CERT, and I'll be presenting digital tools for improving circular flows of secondary materials, part of the Wood2Wood project's first release. This presentation will showcase innovative solutions in this field. So, what exactly is a digital product passport? It's a digital tool designed to boost transparency and sustainability throughout a product's life cycle. Its main purpose is to track every product and its end-to-end lifeline, providing detailed information on every step and aspect of the chain, from creation up to withdrawal, along with the item's current status. For Wood2Wood, this means better oversight of wood materials, ensuring sustainable practices and informed decision-making at every stage. So let's explore how the digital product passport transforms data management. It features a centralized lifecycle data repository, storing structured data on wood materials from collection to reuse or recycling. Traceability is enhanced by tracking origin, treatment history, contaminants, and processing steps for better quality control. It supports circular strategies with real-time insights on material condition, aiding reuse and recycle decisions. Enhanced transparency provides stakeholders with clear sustainability and compliance data. Plus, it integrates with smart platforms like digital twins and AI tools for optimized processes. Next, let's look at enhanced interoperability, a key strength of the digital product passport. It uses standardized data formats to harmonize classification, like material grade and pollutant presence, ensuring cross-platform compatibility. Cross-system communication links ERP and industrial systems, unifying data flows for manufacturers, sorters, recyclers, and regulators. Machine-readable metadata enables AI and machine learning tools to act on DPP data autonomously. It facilitates collaboration by aligning diverse actors, construction, pulp, and chemical sectors through a shared digital language. Plus, its compliance-ready architecture supports future European DPP regulations, ensuring scalability across industries. Moving on to the digital product passports application, the landing page features a clean UI with e-buttons like Wood2Wood project, which leads to home page, Serve, which redirects to Serve's official website, About, Contact, and Login, guiding users with easy navigation. The About page, accessible via its button, gives a brief summary of the product and its main focus. It also displays registered products and users, currently 11 materials and 3 users, which are professional, non-professional, and administrators. Professional users have the ability to view everything and edit through the corresponding buttons of the app. Non-professional users can view everything in the app and contact the admins through the contact form to ask for changes. Administrators can manage anything in the app. These buttons make the DPP a practical, user-friendly tool for the Wood2Wood project. Let's talk a little more about the digital product passport application. The contact page features a contact form allowing anyone to reach DPP administration, inputting a name, an email, and a message. When the login button is pressed, the user gets redirected to the login page, and the previous button is now transformed to sign up button, enabling users to access or join the app. With a simple email and a password field, it's designed for seamless user engagement in the Wood2Wood project. So, how the application brings data to life? The landing page serves as a dynamic dashboard, offering a quick snapshot of crucial product insights like financial overviews. The digital product passport page showcases all wood types on the platform. Currently, 9 types have been added for the Wood2Wood project, enhancing material tracking. Of course, authorized users can take it further. With the right access, they can add new products to the database using the Create New Graph button. This feature helps the team add more to the DPP, keeping the project's data up to date and complete. Let's check out the product profile page. Users can pick up a product and see its details from start to now, like supplier info or material properties, all laid out in simple sections. Plus, the QR code lets you easily download the report of the selected product. Next is how the digital product passport enhances usability. A handy QR code lets you access product info quickly across production. You can download a full report with a tap, update details as needed, or remove outdated data when a product is withdrawn. Plus, there is an option to upload extra files with notes to share insights. This shows how these tools help keep the project on track. So, what's coming up for the digital product passport? We're looking to connect products more closely where possible, building stronger links. We'll also train and roll out AI models to generate quick product summaries and work with the database. Plus, we are adding RAG architecture trained on the database to improve data explainability and make querying easier. Down the line, we plan to add a summarization tool for wood profiles to highlight key details in a short paragraph. We'll ensure everything meets European regulations, keeping the Wood2Wood project on track. So thanks for your attention. I'm here for answers, so feel free to ask or get in touch later. Thanks again.
Thank you very much, Dimitri, for that insightful presentation. We now have some minutes for questions. Please share your thoughts or queries for Dimitris. If there are no questions, thank you very much, Dimitri. And now we have Luis Varkarcel, sorry for the pronunciation, from CEIT here to present on behalf of the DARROW project. Luis will be discussing making wastewater treatment more sustainable and efficient using a data-driven AI solution. So, Luis, you can begin.
Okay. Let me. Okay. Let me share my screen. Can you see my screen?
Yes.
Okay, perfect. Thank you very much. Well, my name is Luis Valcárcel. I'm from SAID, from Spain, and I'm here to present the DARROW project. DARROW project stands for Driving the Future of Water Resource and Recovery Facilities Through Data Intelligence. We are the coordinators, but we are compendium of several of lots of research companies, research center companies, universities, and the final client. And our objective is to optimize resource recovery from the secondary treatment and anaerobic digestion processes while guaranteeing the overall plant efficiency. That is one of the big deals that we have with the Green Deal and our cluster. Our pilot plant is going to be the Tilburg plant, which is one of the biggest wastewater treatment plants that exists in Netherlands. Our objectives, I'm going to try to show them at the same time as I show them where they are located in the plant. Here you can see a wastewater treatment plant in which the influent, the dirty water goes in the influent. We clarify them, go to the secondary treatment, which is where most of the energy is consumed. Then we extract all the sludge and where a lot of bacteria which is eating all the dirt that we have in the water, the pollutants, we can process it in an anaerobic digestion in order to obtain biogas, and then we throw it out. We can use this gas to generate electricity, so we can use it in our own wastewater treatment plant or sell it. Apart from that, the water after the secondary treatment goes to a clarifier and then is clean and ready to go to the effluent to be returned to the environment. So, what are our objectives? By using AI systems to try to reduce the energy consumption by 20%, consume less energy, reduce greenhouse emissions by 20% that are not shown in the display, but this secondary treatment also produces NO2 and some gases are released to the atmosphere, so try to reduce them depending on how you operate the plant. Try to reduce the sludge generator, how much sludge we throw away to landfills or incinerator plants, etc. Try to reduce the chemical consumption we need to include in the plant in order to reduce some of the pollutants that can also be done biologically. And at the same time, by optimizing, we can or reduce the energy we buy or increase the energy we generate, try to increase it, try to increase the nitrogen recovery and the biophosphorus recovery. That are two main pollutants that are also really interesting to be recovered from the wastewater. And also try to increase the effluent quality. So the main problem that we had is that always there have been a wall between how the plants are operated, the data, and scientists, researchers because most of the cases, all the data is offline, the models are complicated and cannot be operated via in real time. So digital twins and Internet of Things and AI is allowing to try to implement these models, reduce their size, and implement them in the real world. So in DARROW, we are having all measurements that are available in a wastewater treatment plant, plus meteorological data and other data. What we want is to obtain different AI tools that allow us to perform an advanced monitoring and scenario analysis, recommendation systems, enabling a closed loop control that optimizes the operation of the plant. Here I'm showing some of the DARROW technologies that we have developing. For example, the advanced monitoring allow us to infer more measurements from some sensors that are in the plant to monitor several parts of the plant using multispectral different sources of information to infer other ones, to measure hidden KPIs that are not possible to be measured directly by sensors or by lab, but that are inherent to the model and evaluate how the plant is working, and also to develop a decision support system based on reduced order models or even automatic controls based on reinforced learning. These are some of the solutions that we are implementing in the DARROW technologies. But for this webinar, in the importance of data and for this Green Deal, all these artificial intelligence models that work really well and are provided great results depends on data. And artificial intelligence is only as good as the data is fed. It requires reliable sensor, real-time data, and robust acquisition system. The problem that we have is most of the field is now developing a data culture. Some of the data is incomplete, noisy, lack of standardization. More importantly, as you can see in the bottom part, is a paper from several years ago. One of the main problems that we have in the wastewater treatment plant, more importantly, in the influent, when the water has more pollutant, is the sensor that drift, in which the measurement drifts deviate from the target measurement a long time due to that the sensor is inside dirty water. That's why this is a problem more in the input of the wastewater treatment plant than in the output. Also, sometimes we have errors in the sensors, or they stop working. And as I showed in the other plot, we can see that some of the measurements suddenly can go to other values that are not real, but sensors are measuring it. This is, once we are deploying the AI, this is a problem that we can have. And this is now more important to be taken into account, because due to the European Union Artificial Intelligence Act, now wastewater treatment plant is a critical infrastructure, as most of the projects that have been presented. And one of the things that for us is really important is that now human oversight is required in the entire process. Full autonomous artificial intelligence control is no longer permitted. Operators must be involved. And models need to be transparent and explainable. So we are not longer able to just develop and implement black box models. We need to make AI, the decisions that they are made needs to be understandable, traceable, and safe. This is one of the steps that I would like to remark in this webinar, that as we are now in a critical infrastructure, human oversight is required. Additionally, data, as we are dealing with digital data, can be attacked. So we need to provide to do it cyber secure. Also, with the new NIS2 directive of the last year, wastewater treatment plant, again, is a critical infrastructure, so it needs to be cyber secure, compulsory. As how it impacts in projects like DARROW on trying to use AI to improve the operation of wastewater treatment plant. Here we have several things like cyber risk management. The AI we implement must be secure. We need to have a good data governance. We need to ensure that data is not attacked, that the models are not poisoned, etc. We cannot use, for the human oversight, we cannot use fully autonomous AI control systems. For the transparency, the black box models are no longer, we cannot longer implement them. We need to provide explainable models. We need to also report incidents to generate physical resilience and legal accountability of the AI decisions. For these projects, the reinforced learning part is a bit, we cannot fully or completely implement it in new plants due to the new legislation, but all decision support systems can be implemented as they just provide a recommendation to the operator, and then the operator decides if it's a good recommendation or not. For the transparency part of AI models, we are developing reduced order models accompanied by which are explainables. Apart from providing a predictions or a recommendation, they provide an explanation on why they are decided in that part. And for the first part, what we need to focus is in cybersecurity. So in our group, some people have been working also in cybersecurity applied to the wastewater treatment plants, as it's becoming a hot topic, not only inside our group, inside of the state, but also globally. There has been efforts in trying to develop new data sets on cyber attacks to wastewater benchmarks, to wastewater treatment plant at lab scale, but generate true cyber attacks. There has been lots of reviews, lots of cyber security incidents in the last year. So this is now becoming a hot topic. And as conclusions for my presentation and this webinar, the integration of AI is going to allow us to increase efficiency, to allow anomaly detection, to optimize the process. However, all these benefits rely on data, and AI systems are secure if they are resilient against cyber threats that allow us not to poison our data that we have in the model. This is not only because we want the model to work, but also because now Europe is in, or has a strict requirement in this topic to generate robust and cyber secure system. This is also a hot topic in academic research. And last but not least, AI and cyber security must evolve together, advance at the same time to ensure sustainability and secure operation of critical infrastructure. Thank you very much.
Thank you very much, Luis. You can now go ahead with your questions if there are any.
Okay. I don't know in the chat is any question.
Okay, so if there are no questions, we thank you again. And we can now continue with Raquel Lascano from Eviden, representing the ALCHIMIA project. Raquel will be sharing insights on boosting industrial efficiency and collaboration through federated learning. Raquel, the floor is yours.
Thank you. Do you hear me and see my screen?
Yes.
Okay.
Yes.
Okay, so hello, as just said, my name is Raquel Lazcano and I'm here representing Alchimia project. I'm here on behalf of Evident, which coordinates the project and also leads one of the main technical work packages. And the talk I'm going to give today is about how federated learning can be leveraged to boost industrial efficiency and collaboration. To put some context, I'm going to first briefly introduce Alchimia. Alchimia is an H2020 project that started back in 2022. So it is now reaching its final stages. And its mission is to provide a platform for the EU metallurgy industry to smooth the transition to efficient production processes, enriching them with AI capabilities. Hence, the main problem Alchimia faces is how to apply AI in this kind of context, with the objective of reducing energy consumption and emissions of the steel sector, favor its green transition, and last but not least, advance in the EU strategy towards AI. To do so, Alchimia faces some important challenges such as data sharing and data access, interoperability, trustworthiness and user acceptance, need for scalable IT infrastructure, and also transferability and replicability. To overcome all these challenges, Alchimia relies on federated learning. Federated learning is a decentralized approach to AI model training where data remains local. This paradigm presents the following advantages. First, it presents enhanced data privacy and security. It also improves the scalability and adaptability of the solutions. It fosters as well the reduced communication and bandwidth of the solution. And last but not least, it leverages, it fosters compliance with AI and data protection regulations. Hence, a federated learning approach is useful in too many scenarios. The first one, where the data hosted in clients is sensitive, so it cannot leave the client's premises. And secondly, when the amount of data hosted in clients is so large that the cost of transferring it is prohibitive. Both cases apply to Alchimia, so federated learning comes as a natural solution. In this context, within Alchimia, Evident has developed its own federated learning framework to solve Alchimia's specific needs, providing a tool that is highly customizable, flexible, and adaptable, for which we have full control of the code and the architecture, and which allows us to tailor the solutions to the specific problem that we have at hand. To get into the details, our framework is based on these three pillars I've mentioned: modularity, adaptability, and customizability. From the modularity point of view, the framework allows us to implement fully customizable federated learning pipelines. Then, regarding adaptability, it enables us to ensure data privacy by leveraging first different privacy preserving techniques. And as well, and additionally, it allows us to adjust to the specific problem at hand by supporting different aggregation mechanisms. And finally, regarding customizability, the framework favors seamless integration across diverse distributed infrastructures and enhances security and process oversight, leveraging MLOps paradigm, which has also been mentioned in a previous presentation. So even though it has been already covered, I'm going to just briefly highlight the main, what is the MLOps paradigm and what are the its main benefits. So MLOps is a set of practices that unifies machine learning system development and deployment. And what it covers is basically it bridges the gap between data science and operations teams. Among the many benefits that this paradigm presents, we have that it accelerates model development and deployment cycles, it improves reliability and compliance of the solutions, and last but not least, it reduces operational costs through automation processes. How we have done this in ALCHIMIA, how we have combined this. So in this slide, we present ALCHIMIA's architecture, which leverages the unique combination of federated learning and MLOps. In this solution, we have a central server that you can see on the right of the screen, and several clients on the left. Each client represents one of the plans that we have as use cases in the project. So by combining MLOps and federated learning, AI models can be trained in a distributed manner, exploiting synergies among the different plans without actually sharing the data, and guaranteeing that the deployments are secure, robust, and scalable. By using this solution, we have already obtained some results. So first, some models have already been federated for the use case led by CELSA, which is one of the main players in the metallurgy industry. And in this use case, we have three different plants: Spain, France, and Poland. In this case, machine learning model have been developed to optimize the internal processes of CELSA's furnaces. And our initial results show that some accuracy improvements in the federated models, which proves the hypothesis upon which ALCHIMIA has been built. Right now, we are finishing the federation of the models for the other use case, which is brought by an Italian metallurgy industry called Fonderia di Torbole. And the initial results obtained with this model are also quite promising. Once we finish with the federation of the models, we are going to put in place a continuous learning system, which is integrated with these federated learning and MLOps capabilities I described. This system will allow us to deploy models in a distributed manner and monitor them so as to be reactive to potential drops in the performance. In the presentation of CLARUS project, where MLOps was also discussed, they also mentioned data drift. So basically, this system is used for this too, for detecting data drift is used as a data drift and model drift in the federated models, and relaunch a retraining. An automatic retraining of the system if the performance is going below a certain threshold. If this happens, this automatic retraining is launched, as you can see in this graph, where, as you can see, in some point in the experiment, this threshold is reached, and in the blue line you can see what would have been the solution without the retraining, and the orange line represents that the error comes now again to an acceptable. The error of the model comes to an acceptable value once the retraining has been launched. Through this system, what we achieve is to increase the robustness of the models that are deployed, and consequently, we enlarge their life cycle. As a conclusion, ALCHIMIA presented these challenges. I opened the presentation with them, and as you can see, thanks to the combination of federated learning and MLOps, we have been able to overcome all of them. Undoubtedly, our main conclusion is that the solution developed in ALCHIMIA can be generalizable, so it can be applied to other sectors, industries, and verticals. To put a couple of examples where this solution is being tested outside of ALCHIMIA, I'm going to put two examples. First, we have successfully tested this solution in a swarm learning scenario where a model predicts the number of crime occurrences in 3 different countries: Belgium, Finland, and Germany, using sensitive data from European law enforcement agencies. Swarm learning has the condition in which the aggregator, the server, is not fixed, but it is changed among the clients, and in that way, the robustness of the system is also increased. Then our second solution, we have also tested this framework in a hierarchical learning scenario that deals with data coming from sensors on industrial machinery measuring the different physical units, such as temperature or pressure. In this case, 2 different models have been proposed, one for the detection of anomalies and another one for sensor data forecasting. And the purpose of hierarchical deployment here is to obtain aggregated models for every machine, which is the first level of the hierarchy, and then for every plant, which is the second level of the hierarchy. So this proves that the solution that we are developing is applicable to many in a very horizontal way and can be reused for other sectors. So this is all from my side, and thank you very much for listening. And if you have any doubt, do not hesitate to ask.
Thank you very much for this very interesting presentation on all this information shared. So if you have any question for Raquel, this is the time. I guess not. So you can, of course, individually approach each speaker. And with that, we've reached the end of today's very informative webinar. So my sincere thanks to all the speakers from Tubers, CLARUS, Reclaim, Wood2Wood, DARROW, and ALCHIMIA for sharing their expertise and demonstrating the vital role of AI, data, and robotics. It's truly inspiring to see all the collaborative efforts making such a significant impact across many industries and infrastructure. So we also hope that you found today's discussion also insightful and provided valuable perspectives on the operations that you do. So thank you for being with us, and we look forward to future collaborations.
Thank you very much for having us.
Thank you very much.
Thank you.
Have a
Thank
good
you.
day.
Have a nice day.
Thank you. Bye-bye.